Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My course is going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, IIT-Jam exam, Jest, uh, TIFR and other exams related to physics. And also I thank you everyone who subscribed my channel, and also I would request the people who haven't subscribed my channel yet, please subscribe my channel. So today we are going today it's a lecture number third of quantum mechanics. Okay, so we are going to study Compton effect. The last time we have studied black body radiation and photoelectric effect, right? So today it's a Compton effect, as I already explained that the classical physics was not able to explain Compton effect, photoelectric effect, and black body radiation. So I have already explained black body radiation and photoelectric effect, right? And also I would request you guys, please watch my previous lectures of quantum mechanics to understand everything properly. Okay. Well, so we are going to study Compton effect today. Okay. So I'll write as well. So it's Compton effect. Okay. Okay. I'll write point. Compton effect. Compton provided the conclusive most conclusive confirmation confirmation of the particle aspect particle aspect of radiation. Okay. First point is the Compton provided the most conclusive confirmation of particle aspect of the radiation. So Compton proved that it says the Compton proved that the radiation is particle. Okay, radiation is made of particle. Okay, so that's what this sentence is saying. The Compton provided the most conclusive confirmation of the particle aspect of the radiation. That it gives proof, that exact proof that the radiation is made of particle, or radiation is stream of particles called photon. Okay, and what Compton has done is Compton irradiated the metal with radiation, with high frequency radiation, high energy radiation, for example X-rays, right? And he found that uh, they got scattered, and also he found the wavelength. The wavelength of scattered radiation is larger than the wavelength of the incident radiation. Okay, so I'll write as well so that you can make notes and it would be easy for you to study. Okay. Okay, so I'll write by scattering by scattering x-rays X-rays of free electron, of free electron, of free electron. He found that the wavelength of the wavelength of the scattered radiation wavelength of scattered radiation is larger than the wavelength of the incident radiation. After this topic, I will solve PYQs related to this topic. Then this thing will get more clearer to you. Okay. Okay. So incident radiation, by scattering X-rays of free electron, he found that the wavelength of the scattered radiation is larger than the wavelength of the incident radiation. Okay. Okay. So this can be explained be this can be explained only by assuming that the X-ray photons X-ray photons behave like particles. Behave like particles. Okay. So this can only be explained. We can explain only if we consider that the particle that the radiation is made of particles called photons. Okay. Next point. Next point is the experimental I will make figure diagram as well, so it will be more clearer to you. Okay. The experimental findings of Compton, okay, reveal that the wavelength of the wave the wavelength of the scattered radiation scattered scattered radiation wavelength of the scattered radiation increases by an amount by an delta lambda by an amount of delta lambda called the wavelength shift. The wavelength shift. Okay. The experimental findings of Compton find experimentally that that the wavelength of scattered radiation, the radiation which got scattered, right, has a larger frequency, that is by an amount of delta lambda, and that delta lambda is called wavelength shift. Okay. And that delta lambda, that is wavelength shift, okay, that wavelength delta lambda depends on depends depends not on the intensity of on the intensity not on the intensity of the incident radiation intensity of the incident radiation. Okay, so it is saying the wavelength shift, that is delta lambda, depends not only, so that doesn't depend on intensity of incident radiation, okay, but only on the scattering angle scattering only on the scattering angle. Okay. Okay, so delta lambda only depends on the scattering angle. Okay, I'll make a diagram now so it will be clearer to you. Okay. uh, well, so I'm going to make a diagram in next page. So suppose this is it's a straight line. Okay, this is the photon. Okay, this is the photon whose energy, incident photon, okay, whose energy is E equal to h nu, and momentum is p. Okay, p is the momentum and E is the energy of this incident photon. Okay, so there is a electron at rest. Okay, that is whose energy is E naught. Okay, and electron at rest. Okay, so now the photon incident on electron. Okay, this is the line, this one, it's a straight line. Okay, so what happens is this photon gets scattered by angle theta. Okay, and this it get scattered, and its momentum is p dash. Okay, momentum is p dash, and energy is E equal to h mu dash. Okay, because and this electron gets recoiled electron by angle phi. Okay, whose energy is E. Okay, and momentum is Pe. P is the momentum and energy is Pe, because it's electrons energy, right? So we are writing it by E. Okay. Okay. So this is the photon of energy h nu, which incident on this electron. Okay, which is at rest. Okay. So what happens is this electron, because of that, this because it's high energy photon of X-ray, right? So it recoils the electron at the angle phi. At the same time, this photon gets scattered at angle theta towards this direction. Okay, so energy of photon now becomes E nu dash, and and momentum becomes uh, p dash. Okay, and the recoiled electron, this is the recoiled electron. Okay, recoiled electron recoiled electron. Guys, I would just like to inform you, my course is not only going to help you to uh, crack the written exam. It is also going to help uh, to prepare for help to crack your interview as well. So you don't need to prepare separately for interview. If you will watch my classes, which are free of charges. Okay, so my courses are going to help for written examination as well as for interview. Okay, so no need of separate preparation for interview. That's why I'm trying to solve everything, and I'm writing as well, so that you can make notes of it as well, right? So it will be easy for you to uh, uh, during the exam time or during the interview, you can easily uh, uh, study it and crack the exam or interview. Okay, so this is a recoiled electron. Okay, this is a recoiled electron. Okay, so this is the Compton effect, right? Okay, so now I will explain how Compton explained it. Okay, so Compton succeeded, succeeded, Compton succeeded in in explaining, explaining his experimental result, his experimental, his experimental result, his experimental result only after, only only after treating the incident radiation, treating the incident treating the incident radiation as a stream of particle, as a stream stream of particle stream of particle stream of particles which are called photons. Okay, colliding with individual electrons, with with individual electrons. Okay, Compton succeeded in explaining his experimental result only after treating the incident radiation as a stream of particles, that is photons, colliding with individual particles. Okay, so Compton treated the incident radiation as a stream of photon. Okay, and they are colliding with individual electrons. Okay, next. So I'll derive the formula as well. Okay, so consider that. Okay, right. Consider that consider that the instant photon the incident photon there is difficulty in writing. The instant photon of energy of energy of energy equal to h nu. Okay, and momentum and and momentum and momentum I have written and momentum p, okay, equal to h nu upon c. Okay, this is the momentum, right? This is the formula for momentum. H nu upon c collides with an electron with an electron that is initially at rest, that is initially at rest. Okay, if the photon scatters with if the photon scatters with with momentum P, with momentum P at angle theta, while electron recoils, while electron recoils with momentum PE. I have already explained here, right? This is the diagram, so it's clearly explained in diagram. The scattering angle is theta, and the recoil electron makes angle phi. Okay, and this is P. The momentum of recoiled electron is P. Okay, okay. So now we will use conservation of momentum and conservation of energy to derive the Compton the Compton length. Okay, for driving Compton length, the Compton shift. Okay, or shift in wavelength, or we can say wavelength shift. Okay, so we'll use conservation of momentum first. Okay, so conservation of momentum will be like P. This is the incident uh, momentum of incident photon is going to be equal to P dash minus P dash plus P. Okay, so this is the momentum of incident radiation after scattering. The momentum of incident the scattered radiation is P dash, and momentum of recoiled electron is PE. Okay, PE, PE, momentum of recoiled electron. That I have explained here in diagram, right? The PE is scattered the angle of scattered recoiled electron, and this is the momentum of recoiled electron. Okay, P dash. So we have used the conservation of momentum. Okay, so now we'll solve it. So here we can find out PE. It is going to be PE square. P square is going to be P minus P dash. Okay, whole square. So we'll open it. It is going to be P square is going to be P square plus P dash square. Momentum is vector quantity, so I'm not writing this arrow. It's getting complicated. Okay, so it is going to be minus 2. We'll open it, right? So P dash, angle between them is theta. Okay, this angle, this one, this is the angle, right? This is theta. Okay, so now we'll write value of P, that is h nu upon C, right? So we'll put it, and this value is going to be, after putting h square upon C square. Okay, we take it as a common, so it is going to be mu square plus mu dash square minus 2 mu dash cos theta. Here we have put this one. The value P equal to h nu upon C, and P dash, the value of P dash we have put, that is h nu dash upon C. Okay, and after putting value, p is value of p square is this. This we can say this is equation number 1, and this is equation number 2. Okay. Okay, let me just check is my internet working fine. Okay. Okay, so next we'll use conservation of energy. Conservation of energy. Conservation of energy. Okay, so we know E naught, that is rest mass energy, is going to be E naught equal to me c square. Okay, me c square. M is the mass of electron. Hmm. So and so we can easily find out E. This is the rest mass energy. Okay, so E, that is energy of electron. Okay, that is going to be root E square, E square, C square plus Me, Me square mass of electron, e to the power 4. Okay, so E, that is energy of electron, is going to be that is we'll put the value of P, that is h nu upon c. So after putting value, it is going to be h root, we'll take h as common, mu square plus mu dash square. Okay, minus 2 mu dash cos theta. Okay, and then we'll put this value, so this is going to be plus me square e to the power 4 upon h cut h square, sorry, h square. Okay, this is the value. So now we'll use conservation of energy. So implies conservation of energy, that is E is the energy of incident radiation, and then E naught, that is the rest mass energy of electron, is going to be E dash, that is the energy of scattered radiation, and plus EE, that is energy of electron, right? This is the energy of electron when it is at rest. Okay, so now we'll put the value. This is going to be mu minus mu dash. Okay, we'll first put the value, sorry. So it is going to be, and the value of E is h mu plus E naught. It is me c square equal to, this value is h mu dash plus value of E is this h root mu square plus mu square dash. Okay, minus 2 mu dash cos theta plus m me square c to the power 4 upon h square. Okay, we have put the value. Now we'll simplify it. So it is going to be mu minus mu dash, will take h mu dash in left hand side, plus me c square, me c square upon h, and that is the h also will will be here, and this is going to be nu square plus nu dash square minus 2 nu dash cos theta plus me square c to the power 4 upon h square. Okay. Okay. I'm just checking if there are any technical issues. Okay. Okay. So now what we are going to do, this is the equation number third. Okay, we are squaring on both sides and simplifying. So after doing that, we are going to get the value, that is 1 upon nu dash minus 1 upon nu is going to be h upon me c square into 1 minus cos theta. Okay, this is the one. Okay, so now since we know nu equal to c by lambda, putting this value, so we are going to get delta lambda equal to lambda dash minus lambda. Okay, so that is going to be h upon mc, h upon mc, mec. Okay, mec, this is mass of electron, h upon mec into 1 minus cos theta. Okay, so this is called wavelength shift. Very important formula. Okay, right? Wavelength. So delta lambda is called, where this is wavelength shift. Okay, that is delta lambda is wavelength shift. Okay, delta lambda is wavelength shift. Is called wavelength shift. Okay, delta lambda. And here lambda c is equal to h upon mec. Okay, and this is called Compton wavelength. Okay, Compton wavelength. Compton wavelength. Okay, this is called Compton wavelength. Lambda c equal to h upon m naught c equal to Compton wavelength, and its value is equal to, after calculating, the value is 2.46, 2.426, 2.426 into 10 to the power minus 12 meter. Difficulty in writing. Okay, minus 12 meter. Okay, this is the value of lambda c, that is Compton wavelength, and this is called wavelength shift. Okay, this formula is very important. This formula is very important, so note down it. Okay, we will solve questions related to this. many questions are asking different competitive examinations of physics. Okay. Well, so so here in summary we can say the Compton effect. The Compton effect. Compton effect confirms that photons photons behave like behave like photons behave like particle particle particles. Okay. They collide they collide with electrons like material particle Okay. So Compton effects gives proof that photon, the radiation is made of photon. Yeah, radiation is made of particles. Radiation that's actually that tells the Compton effect tells and gives the most conclusive confirmation of particle aspect of radiation, right? So means photons or radiation uh, is stream of particle. That's what Compton effect proves. Okay. Well, so this formula is very important. Okay, you need to note down, and we'll solve question based on the formula. So now I hope guys you understood Compton effect. Compton effect means when any metal is irradiated with radiation of high energy like X-rays. Okay, we have found that it scatters it gets scattered, and we have experimentally found that and also we have explained the Compton explained it theoretically as well. So we have found that uh, the wavelength of scattered particle is larger than the wavelength of incident photon. Okay, that is incident radiation. Okay, uh, and we have proved it. So it's a very important topic. Okay, well, this is the Compton effect. Let me just check my internet connection. Okay, it's fine now. Okay, so it's a very important topic, and this Compton effect we were able to explain by quantum physics. Okay, so classical mechanics was not able to explain the Compton effect. Okay, guys. Okay, so now there is some formula as well. I'll write it for you. Important formulas. So that is kinetic energy of recoiled electron. Kinetic energy of recoiled electron. This one. Okay. This one. Kinetic energy of this recoiled electron's kinetic energy. Uh, we are going to find. Okay. I'll not derive it. I will write the formula, and we'll solve questions based on those formulas. Right. Okay. So kinetic energy of recoiled electron is that is K equal to equal to h nu alpha 1 minus cos phi upon 1 plus alpha into 1 minus cos phi, where phi is the angle of recoiled electron. Okay, recoiled angle you can say. So where the value of alpha is h nu upon value of alpha is h upon h is Planck constant. Okay, me c square. Me is mass of electron. H upon alpha equal to h upon me c square. Okay, this is h nu upon, sorry, yeah, h nu upon m naught c square, or m naught c square, or me c square. Okay? This is the rest mass. So me c square, mass of electron, which is at rest. We can yeah. So this is the value of alpha. Okay, this is the kinetic energy. Important formula. You will get many questions. Okay, so kinetic energy of recoiled electron is this, where alpha is h nu upon me c square, or h nu upon m naught c square. That is rest mass of electron. Okay. Okay, and one more important formula is here. That is direction of recoiled electron. Direction of recoiled electron. Direction of recoiled electron. Okay, so that is cos phi by 2 is going to be equal to 1 plus alpha 10 1 plus alpha 1 plus alpha 10 theta. Okay, by that you can by this formula you can find out the direction of recoiled electron. Okay, and here so this is clear from the figure, theta and phi, right? This is the figure. So theta is the angle, recoiled angle, and phi is the scattered angle. Okay, scattering angle. Okay, so you can easily find out the direction and kinetic energy of the recoiled electron from the formulas which I have written. Okay, so value of alpha, that is h nu upon me c square. Okay, this is the value of alpha. Okay, so guys, now the theory part of Compton effect is completed. Okay, so now I'm going to solve some questions related to this uh, this topic, that is Compton effect. Okay, question number first. Question number first is, it is asked in IIT-Jam 2008. Okay, IIT IIT-Jam 2008. Okay, this is the question. Okay, the question is, a photon of wavelength lambda, a photon of wavelength, lambda is is incident on is incident on a free electron at rest, a free electron, a free electron, a free electron at rest, okay, and is scattered in the backward direction, and is is scattered in the backward direction, in the in the backward in the backward direction, in the backward direction. The functional shift in its wavelength, the functional shift, the functional shift in its wavelength, the functional shift in its wavelength in terms of Compton wavelength, in terms of Compton wavelength, lambda c is, okay. Options are, option number A is, okay, so this is the question in IIT-Jam 2008, okay, which is asked in 2008, and options are, option number A is lambda c upon 2 lambda, option B is 2 lambda c upon 3 lambda, and option C is 3 lambda c upon 2 lambda, and option D is 2 lambda c upon lambda, 2 lambda c upon lambda, okay. So these are the options. Okay, question is, a photon of wavelength lambda, okay, is incident on a free electron at rest. So electron is free at rest, and photon of wavelength lambda incident on it, okay, and is scattered in backward direction, and that photon, after scattering with the electron, uh, after colliding with the electron, scattered in the backward direction, okay. So the functional shift in its wavelength, so you need to find out the shift in the wavelength in terms of Compton wavelength, lambda c, right? Okay, so we are going to solve it. Solution. Okay, the solution is, since we know 15 lambda, okay, wavelength, that is lambda c into 1 minus cos theta. Okay, this is the formula, guys, where lambda c is h upon m c, right, or m naught c. So this is the formula, but we have to find out in terms of Compton wavelength, that is lambda c. This is Compton wavelength, okay. Okay, So also it is given that photon scattered in the backward direction. Okay, so photon scattering angle, the backward direction, photon scattered in backward direction means scattering angle is phi 180 degree, right? Phi degree, sorry, phi 180 degree. Backward direction means 180 degree, that is theta equal to phi, right? We'll write the value. So delta lambda equal to, that is shift in its wavelength. Delta lambda is going to be equal to this one, lambda c into 1 minus cos phi. The value of cos phi is delta lambda equal to lambda c into 1 minus value of cos phi equal to minus 1, right? So delta lambda is going to be 2 lambda c. Okay, so this is the shift in its wavelength, but we have to find out functional shift, right? This is the functional shift in its wavelength. Functional shift means we'll divide this by lambda. Okay, so functional shift functional shift is going to be delta lambda upon lambda, right? So this is the functional shift. Okay, we'll divide shift in wavelength by the wavelength. Okay, so that is going to be delta, the value of delta lambda is 2 lambda c upon lambda. So this is the answer. Okay, so 2 lambda c upon lambda, which option is matching? Option B is 2 lambda c upon lambda. This is the answer. Okay, so this is the question of IIT-Jam. Okay, next question we are going to do. Next question is, okay, just checking the question. System is working slow. Okay, this is also very good question. Question number 2, and this question is asked in IIT-Jam 2017. Okay, IIT-Jam 2017. The question is, the X-ray of 20 kilo electron volt, the X-ray of 20 kilo electron volt 20 kilo electron volt energy 20 kilovolt energy is scattered inelastically 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 from from a carbon target from a carbon target from a carbon target, the kinetic energy the kinetic energy the kinetic energy the kinetic energy transferred to the recoiling electron recoiling electron by by photons scattered at 90 degree with respect to incident beam with respect to incident beam is kilo electron volt. We have to find out in kilo electron volt. Okay. So question is the X-ray of 20 kilo electron volt energy. Okay, is scattered inelastically from a carbon target. Okay, the kinetic energy transferred to recoiling electron, the energy which is transferred to recoiling electron by photon scattered at angle which is scattered which is scattered at 90 degree with respect to incident beam is. So we need to find out the kinetic energy which is transferred to recoiling electron by the uh, photon we need to find. Okay, and also Planck constant is given Planck constant, that is given h equal to 6.66 into 10 to the power minus 34. Speed of light given, that is c is given 3 into 10 to the power 8 meter per second. Okay, and mass of electron is given, that is 9.1 into 10 to the power minus 31 kg, and electronic charge, that is E, is given, that is 1.6 into 10 to the power minus 19. Okay, this is given, guys. Okay, so now we'll find out. Okay, so I'm going to solve it. Solution. Okay, so the energy is given, that is right, h nu, that is 20 kilo electron volt, and we need to find out the kinetic energy of we need to find out which is transferred to recoiling electron by photon which is scattered at angle theta, right? And we know the formula, that is delta lambda equal to lambda dash minus lambda equal to h upon mc, mass of m is mass of electron, h upon mc into 1 minus cos theta, and theta is given, that is 90 degree, that is pi by 2. Okay, that the photon scatters after transmitting energy to recoiling electron. Okay, so we'll put the value, so it is going to be lambda dash minus lambda equal to h upon mc into 1 minus cos pi by 2, right? And value of cos pi by 2 is cos 0. Okay, so it is going to be lambda dash minus lambda, this value is going to be h upon mc, m is the mass of electron, okay, because this value is 9, and cos 90, cos pi by 2 is 1, okay, cos pi by 2 value is 1. Okay, so now we can also write, because we know E equal to sc by lambda, this formula we know, right? So value of lambda is going to be, implies value of lambda is going to be sc upon E, right? Okay, so this is E equal to sc by lambda. Okay, now we'll put the value here. Okay, so it is going to be lambda dash is going to be h. Okay, so here we can write lambda dash lambda dash lambda dash upon hc lambda dash upon hc minus lambda upon sc, okay, that is going to be equal to, we can write here, right, 1 upon mc square. Okay, so here we'll write it, it is going to be this value, lambda dash upon sc is going to be 1 upon uh, 1 upon e dash, right, by this formula. So it is going to be 1 upon e dash minus 1 upon e, because this one h upon lambda upon sc is going to be 1 upon e by this formula, right, and this is going to be equal to 1 upon mc square. Mc square. Okay, uh, because we know E equal to mc square, right? E not equal to. Okay, so we'll solve it. So we have to find out the value of recoiled electron. So it is going to be 1 upon E dash. This is the recoiled electron value of recoil, the kinetic energy transferred to recoiled electron by photon. Okay, how much energy photon has transferred to the electron? That's what we need to find out, right? E dash, that is photon's energy, that is going to be 1 upon mc square plus 1 upon E. Okay, so the energy which is given by photon to recoiling electron, that's what we need to find out, and E dash is that energy, right? The energy which is given by photon to the electron. Okay, so we'll put the value now, which is going to be 1 upon, we'll put the value here. So value of m we know, that is 9.1 into 10 to the power minus 31. Okay, 1 upon 9.1 into 10 to the power minus 31 into 3 into 10 to the power 8 whole square plus. So we'll directly, I think we will not write like this. Okay, because we have to find out value in kilo electron volt. So directly we know the value of this mc square, that is going to be 1 upon 0.5 MeV. 1 upon mc square, value of mc square is MeV. Okay, plus 1 upon EV we know, right? It is 20 kilo electron volt. So we'll convert this into kilo electron volt. So this is going to be 5 into 10 to the power 3 kilo electron volt plus 1 upon 20 kilo electron volt. Okay, this is the given. I'll show you. This is the given. Okay, this is the energy of X-ray. Okay, so because here we know 1 MeV is 1000 kilo electron volt. Okay, so we did it and we'll solve it, and after solving, the value of E dash, which is 1 upon E dash. Okay, value of E dash is going to be equal to 19.2323 19.23 kilo electron volt. This is the answer. Okay, this is a numerical type question. Okay, we have to find out the answer. So E dash is this. The kinetic energy. Question is the kinetic energy transfer to recoiling electron. And just let me put the kinetic energy transfer. So this is the energy, right? Okay, so this is the one. Let me just check now. Connection. Is it working fine? Okay, so now this is the energy of scattered electron. Okay, this is the energy of scattered photon actually. But we need to find out the kinetic energy transferred to recoiled photon. So the energy of recoiled photon, right? We need to find out. So in that case, it is going to be energy of recoiled electron is going to be total energy of X-ray minus scattered energy of X-ray, E dash, right? So this is going to be total energy 20 kilo electron volt, 20 kilo electron volt minus 19.23 electron volt, 23 kilo electron volt, 23 kilo electron volt. That has solved there. Okay, so it is going to be 0.77 kilo electron volt, and this is the answer. Okay, I'll summarize this question to you. Okay, so what question is saying, the X-ray of 20 kilo electron volt energy. So there is the X-ray whose energy is 20 kilo electron volt, is scattered inelastically from a carbon target. Okay, so that strikes on carbon target, and electrons get recoiled, and that X-ray gets transferred or gets scattered. Okay, now kinetic energy transferred to recoiling electron. So the energy which is transferred to recoiling electron, that is we need to find out, and by photon scattered at 90 degrees. Okay, and photon the scattering angle is given, right? So what we have done is, so this is the Compton shift, that is the shift in wavelength that we find. Here what we have done, we know E equal to SC by lambda, so it means 1 upon E is going to be, right? So we know that S dash upon SC minus H upon SC equal to 1 upon MC square, right? Conservation of energy, right? By conservation of energy, and then we have solved it, E, and we have found E dash, that is the energy of scattered photon. So energy given to recoiling electron is going to be total energy, the energy of incident photon minus energy of scattered photon, E minus E dash, and this is the answer. Okay guys, so well guys, I will stop here, and thank you so much for watching my video, my lecture, and I would also request you, the people who haven't subscribed my channel yet, please subscribe my channel. Okay, and okay guys, thank you so much. Bye now.